Hello everyone, welcome to Site Programming channel. Today in this video we are going to discuss how to solve a knapsack 0 by 1 problem using backtracking method. So before solving this problem, let us discuss what is knapsack. Well, knapsack specifies the commonplace problem of holding weights and profit values of the items where the weight should not exceed the limit and profit should be maximum. Here, it clearly states that we need to hold the weights which should not exceed the maximum weight and we should gain more profit. Let us see an example. Here, let us consider a bag of maximum weight 6 units. So, we have to place the weights in the bag which should not exceed the maximum weight. And now let us discuss about backtracking. Backtracking is an algorithm to solve some computational problems until we get the solution. And backtracking name itself suggests that we are going back and coming forward. If it satisfies the condition, then return success. Else, we go back again. It is used to solve a problem in which a sequence of objects is chosen from a specified set so that the sequence satisfies an criteria. In this point, we can clearly observe that if the condition satisfies, it goes on moving like downwards. If the condition fails, we have to backtrack. We have to move upside. And let us see an example. Here there is a problem where I am considering the objects x0, x1, x2, x3. Each object has a particular weight and a profit, where x0 having a weight of 2 and profit of 4, and x1 having a weight of 3 and profit of 5, and x2 having a weight of 4 and profit of 7. As usual, x3 has a weight of 6 and profit of 8. And I am considering the capacity of maximum 9. Now let us solve this problem using state space solution, which is in a tree format. So in tree format, we can find roots where each root is divided into two parts. First part is known as weight part and the second part is known as profit part. Initially, parent root having 0 values, and we can choose as two ways. First one is considering the object, next one is not considering the object. Here x0 is equal to 1 represents considering the object and x0 is equal to 0 representing that not considering the object. Now let us solve the problem. First of all, I am considering the x0 object which is having weight of 2 and profit of 4. So here it looks like. Now let us consider x1. By x1 is equal to 0, add the weights and profits of x1 to x0. We get 5 and 9, which means here the weight is 5 and the profit is 9. So the maximum profit is 9. Maximum weight is 9. So we can have more space. We can move forward. So let us consider x2, which is having weight of 4 and a profit of 7. By adding x2 object, we get weight of 9 and profit of 16. Our maximum limit is 9 and we got the weight as 9. So here the condition satisfies and we get a profit of 60. Now here we can't move to x3 object because the limit exceeds. We got the maximum weight of 9. So now let's backtrack to the parent node and let us not consider x2. So if you are not considering the x2, the parent node having the values should have the child node. Here it looks like. Now let us consider x3 object, which is having a weight of 6 and profit of 8. By adding a x3, it looks like weight is having 11 and profit is 17. Here the weight exceeds, which means the condition fails. Again we have to backtrack to the parent node and let us not consider x3. So we get the values of weight of 5 and profit of 9. Here it looks like we have reached all the objects. Here the condition fails. We are having a capacity of 9, but we are having capacity only 5. So here the condition fails. So now we should have to backtrack to the parent node where only single child has appeared. Please make a note that every parent node should have 2 child nodes. So here I am having at x1. So now let us not consider x1. So as usual, if you are not considering the x1, we should have to put the values where the parent node is having the same values. Here it looks like. Now let us consider x2, which is having weight of 4 and profit of 7. By adding these values, here it looks like, which is having weight of 6 and profit of 11. So here still we have some chance to put some weight. Now let us just put x3 values. So by adding the x3 values, the weight is 12 and profit is 9. Here the weight exceeds, which means the condition fails. Now we should have to backtrack to the parent node and let us not consider x3. So place the values which is having a parent node 6 and 11. So it seems that we have reached all the objects and weight is still insufficient. So here the condition fails, and now let's backtrack. At this point, let us consider x2 is equal to 0, which means we are not considering the x2. So put the values where the parent node is having a weight of 2 and profit of 4. And let us consider x3. So by considering x3, which is having weight of 6 and profit of 8, by adding the x3 values, here it looks like, which is having weight 8 and profit of 12. So we are having some chance, but we have reached all the objects. So there is no chance to put weights. Again here the condition fails. So now let's backtrack and let us not consider x3. By not considering x3, put the values which are in parent node, having weight 2 and profit of 4. So here the condition fails because we have reached all the objects. And now let's backtrack and let us consider x0 is equal to 0, which means we are not considering the x0 object. So put the values which are in parent node as usual. And now let us consider x1, which is having weight of 3 and profit of 5. And let us consider x2 because here our maximum capacity is 9 and here the capacity is 3. So we have chance. By considering x2, here it looks like, which is having weight of 7 and profit of 12. So let us consider x3. By adding x3 values, here it looks like, which is having weight 13 and profit of 20. Here the weight exceeds, so automatically the condition fails. And now let's backtrack by considering x3 is equal to 0, which means we are not considering x3. So put the parent values 7 and 12, even though the condition fails because we have reached all the objects. Backtrack to x2 and consider x2 is equal to 0, which means we are not considering x2. Put the weight 3 and profit of 5 and consider x3. x3 is equal to 1, which is having weight 6 and profit 8. By adding these values, we can get weight of 9 and profit of 13. Our maximum capacity is 9 and we got the weight as 9. here the condition satisfies and we got another solution. So here the maximum profit is 13, which means here the condition satisfies. Here we don't have any other weights to add. So now let's backtrack, which means we are not considering x3. Put the values as parent in the parent node, which is having weight 3 and profit of 5. We have reached all the objects, right? So here the condition fails, and now let's backtrack. So by doing the same manner, here it looks like the remaining solution. So in this entire solution we got two solutions, which first profit is 16 and the second profit is 13. So this is the video. Thanks for watching. Please like, share, subscribe for more videos.